So, welcome to What's Up Over Edmonton. My name's Jeff Robertson, and I'm a member of the Royal Astronomical Society of Canada Edmonton Centre. So, I will share my screen here. And we're going to start with a picture, and this is something my wife actually took. She was taking pictures of smoky sunsets, and then she showed me this picture, and it says, "Is that a sunspot?" And yes, so there we have a picture of a sunspot without a proper solar filter, but the smoke was so thick that it appeared in her image. So I call this What's Up Over Edmonton because the skies over Edmonton here at 53 degrees north latitude are a lot different than what's presented in popular astronomy magazines, and also what's talked about by astronomy columnists on the radio, notably the guy on CBC radio all the time, talking about stuff you can see at this time of year at 9:30 when the sun is still up here. So here is Toronto on July the 5th, well, today, at 11 o'clock. And I always point out this constellation here, which is Scorpio, the Scorpion, fully above the horizon. We're here in Edmonton tonight at 11 o'clock. This is about as much as Scorpio as we're ever going to see in Edmonton. Just the top half of it, no skin, no stinger or anything like that. Also, it's not only what we see, but how we see it. And this is a picture I took of the moon, Jupiter and Venus back in February. And you can see they're all in a bit of an angle. And on that same night, my wife's cousin, who was in Buenos Aires, Mexico, took a picture of the same alignment. And they're at 23 degrees north latitude, and they're all in a straight line, not an angle. So we see different things, and we see things differently here in Edmonton. Most of the information I use comes out of the Observer's Handbook. It's 352 pages of just about anything the amateur astronomer could ever want to know for making his observations. So what do we got in the sky in July? We have lazy, hazy dog days of summer. We got Catch You Later Venus. Venus is going to be leaving us after being in the evening sky for quite a few months. We've got Earth at aphelion. That is, it's at its furthest point from the sun. We've got Saturn returning to the late evening sky at month's end. Noctilucent clouds are still in season. It's been kind of a slow season this year, but I have seen them a couple times, and other people have seen them, I think, 5 or 6 times so far this year. And as the month ends, so does perpetual twilight. So I will start the planetarium portion. As always, I've pre-recorded it, and I always try and keep it short, but this one went 20 minutes, so I do apologize. So here we go. So looking at what to see in the skies around Edmonton for the month of July, let's start, as we always do, with sunrise and sunset times. So today on July the 5th, the sun rose at 5:12 a.m. It will set at 10:04 p.m. for 16 hours and 51 minutes of daylight. There is no night, as we are still in perpetual twilight. On July 31st, the sun rises at 5:47 a.m. and sets at 9:31 p.m. for 15 hours and 44 minutes of daylight. Perpetual twilight ends on that day, so we have a little bit of night, not a whole lot. It begins at 1:18 a.m. and ends at 2:02 a.m. Let's look at the planets in July, and we'll start with Venus, which has been with us for many months, and it has been dominating the evening sky. But its time is over in July. It will disappear from view, passing in front of the sun and emerging in the morning sky. So I've set the time for 10:35, and tonight Venus is still fairly high up in the sky, easy to spot. It's blazing brilliantly. at magnitude 4.47. So it will look like an airplane landing light. Through a telescope, Venus will be taking on a crescent shape, and that crescent will get thinner and thinner throughout the month. So here it is on the 5th, here it is on the 15th, and by the 20th it's got a fairly thin crescent, although it will be getting fairly tough to see by then. On the 20th at 10 o'clock, it's just above the horizon. On July the 5th, Venus is setting at 11:41. By the 31st, it's setting at 9:29, which is only 2 minutes before the sun sets. And as this illustration shows the path of Venus, this apparition, it's really dropping down toward the horizon fairly quickly. The best time to see a crescent Venus is actually during the daytime. So if you can find Venus in your telescope, be careful not to point it at the sun, or even better, if you're in the area, come on down to the RASC Observatory in Coronation Park outside of the TELUS World of Science. I understand it will be open during the summer months, during the daytime, and you can see the crescent Venus throughout July in the daytime sky. Mercury puts in an appearance in the month of July. It's going to remain fairly low on the horizon, but it will be possible to see it, especially later on in the month. For example, this is Mercury half an hour after sunset on July the 6th, on July the 10th, on the 15th, and on the 20th. On the 28th of July, Mercury is very close to the bright star Regulus. It will be fairly close to the horizon in the twilight, but it may be possible to see those two objects, particularly binoculars or a small telescope. Mercury reaches its greatest eastern elongation early in August. Moving on to Mars, Mars just keeps hanging around. It will be in the evening sky until November, when it passes behind the sun from our point of view. But it is setting earlier and earlier. On the 5th, it's going to set at 11:41, and by the 31st of July, it's setting at 9:29. Looking at Mars, even through a fairly large telescope, this is about all you're going to see. It's going to be an orangey red disk. You won't be able to see any surface features on Mars. On the 9th and 10th of the month, there's the 9th, there's the 10th, Mars will be fairly close to the giant blue star Regulus, the heart of Leo the Lion. Moving on from the evening sky, we'll look at the giant planets, the land of the giants, and for that we have to go into the sky in the middle of the night, or the morning sky. So we'll start with Saturn. On the 6th of July, it rises at 12:09 a.m. By the end of the month, it's rising at 10:30 p.m. And Saturn, with its beautiful ring system, is in the constellation Aquarius. And as I mentioned before, the rings are starting to close up. They're not as wide as they were a few years ago. But it is a magnificent planet to view in a telescope. It is one of the highlights for first-time viewers, for sure. Moving down to the ecliptic, we come to the planet Neptune, the farthest planet from the sun in our solar system. Major planet. Sorry, Pluto. And through a telescope, you will see this lovely blue disk, and you might even be able to make out its giant moon Triton, which is this guy right here, with a medium to large size telescope. At the beginning of the month, it is rising at 12:39 a.m., and by the end of the month, it's rising at 11 p.m., so it is moving into the evening sky. Continuing down the ecliptic, we come to Jupiter, the largest planet in our solar system, the king of the planets. And it is residing in the constellation Aries, the ram, or the hockey stick, I suppose. At the beginning of the month, Jupiter is rising at 1:49 a.m. By the end of the month, it'll be rising at 12:18 p.m., so it is moving into the evening skies well. Throughout the fall and winter, Jupiter will be well placed for viewing. can watch the dance of its moons, and you can watch the planets spin and see the great red spot come into view with a medium to large size telescope. There it is, coming in off the left hand side of the planet. And as I've mentioned many times, you can watch the 4 big Galilean moons, Ganymede, Europa, Io, and Callisto, as they dance around the planet. And this is just a view day to day of those moons moving around Jupiter. And finally, as we move down the ecliptic, we come to Uranus, the 7th planet from the Sun, the first planet discovered in historical times. At the beginning of the month, Uranus rises at 2:08 a.m., and by the end of the month, it is rising at 12:31 a.m. Uranus is moving into the constellation Taurus, and which is one of those constellations that seem to be in the sky for an awful long time during the year. Through a telescope, Uranus presents a light blue or even an aquamarine disk, and in a medium to large size telescope, you may even be able to make out some of its moons. Checking on the moon was full on the 3rd. On the 7th, the moon is south of Saturn. It is near Neptune on the 8th and 9th as it passes below it. It is near Jupiter on the 11th and 12th. And on the 13th, it is passing Uranus. A waning crescent moon is below the Pleiades on the 13th of July. The moon is new on the 17th. On the 18th and 19th, a very slim crescent moon passes by Mercury, and on the 19th, it makes a triangle with Venus, Mercury, and the moon. It is in fairly bright twilight, so it may be difficult to see. And then on the 20th, anniversary of man landing on the moon is just above Mars in the evening twilight. On the morning of the 29th of July, we have the South Delta Aquariid meteor shower, and this is Earth passing through the trail of comet 96P Macholitz, which is a 5.29 year period comet. You can see an average of 10 to 20 meteors an hour. Get away from city lights, dress warm, and take lots of bug spray. Saturn is near the radiant, which is seen here, and there is no moon in the sky that night. Throughout July, we are still in perpetual twilight until the very last day. But perpetual twilight does give us some things to look at in the night sky, even though we will have that consistent glow in the north. We will have satellites to look at. Throughout the night is prime satellite watching season. You can see them all night passing overhead, some going from west to east, some going from north to south. But for those who stay up all night, the International Space Station has several good passes throughout the night. None of them are in the evening hours. They're all after midnight. For example, here's one tonight, which begins at 3:42 when the ISS comes over the horizon and goes really high across the sky. It gets up to 62 degrees high in the sky, which is about as high as the ISS ever gets from our latitude. And you can follow it for a full 7 minutes. And here is a chart showing some ISS times through the early part of July. There are many skilled astrophotographers who actually photograph the ISS as it passes over, and this is a picture taken by one of our members. And of course, something else you can see during perpetual twilight are noctilucent clouds, or night shining clouds. These are clouds high up in the atmosphere, about 80 kilometers above the surface of the Earth, that are made up of icy particles that the sunlight shines upon, even though it is dark on the surface. These clouds are still illuminated by the sun because they are so high up. And we've had a few displays this year, not as many as previous years, but we've also had a lot of smoke and clouds and such. There have been some fairly nice displays this year, and as I talk, I am showing some pictures taken by some of our members this year of noctilucent clouds. NLC season goes on until about the middle of August, and by then the sun is too far below the horizon to shine on the clouds while it is still dark here on the surface. Tomorrow, July 6th, the Earth is at aphelion, that is, it is at its farthest point in its orbit from the Sun, 152,093,251 kilometers away. If you take a photograph of the Sun tomorrow, properly shielded of course, and then compare it with a photograph you'll take on January 2nd, 2024, when it is at perihelion, that is 147,098,925 kilometers away from the Sun, you can see a slight difference, as this photograph I'm showing here shows. So let's have a look at some other things we can see in the night sky. And for this time, I've set the time for midnight on July the 16th, so in the middle of the month. Now, this is kind of what the sky is going to look like in the middle of July. At midnight, it's still going to be somewhat bright with perpetual twilight. So let's just make things a little bit darker here. There we go. So, looking straight north, we can see the bright star Capella here. And it is the star that features prominently in many photographs of noctilucent clouds, because of course noctilucent clouds are in the north part of the sky, and Capella is quite a bright star and shines through them. And as we look into the northwest, we see Ursa Major, the Great Bear, and the familiar part that most people recognize is the Big Dipper, or the Plow if you're English, right here. And if you follow the arc of the handle of the Dipper, or the arc of the tail of the bear, and go down, you come to the bright star Arcturus, which is the brightest star in the summer sky. And if you spike from Arcturus straight down, you come to the bright star Spica in the constellation Virgo. Looking slightly into the northeast, we see the constellation Perseus, which will figure prominently next month because the radiant for the Perseid meteor shower originates in this constellation. Now, there is an interesting star in Perseus, and it is this fellow here, Algol, the demon star. And it is referred to the demon star because its brightness changes quite rapidly. It's a variable star. It's actually an eclipsing binary. There is a smaller star that orbits the main star, and as it passes in front of it, the brightness changes quite dramatically. It changes over the course of just a few days. So if you want an observing project that'll only take a week or so, observe Algol and watch its brightness change over the course of a few days. Of course, was given the name of demon star because stars were not supposed to change. The heavens were the home of the gods, or God, if you will, and things don't change in the god's home. Next to Perseus is Pegasus, the great winged upside-down horse. There's his back legs, there's his body, the great square of Pegasus. And there's his head, there's his other front legs there. And you can use 2 stars in his legs to point directly to M31, the great galaxy in Andromeda. You can see it in binoculars. You can even see it in binoculars in the city, although all you'll see is a smudge where the nucleus is. Even the telescopes in our observatory in Coronation Park by the Telus World of Science, all we can make out in the city light pollution is just this smudge where the nucleus is. You cannot see the spiral arms in the city. You have to get away from the city. But if you are in a dark site and you do have a pair of binoculars, yes, you can make out the spiral arms. And of course, a telescope will show you more detail. Moving up from Andromeda, you come to Cassiopeia. And lying as it does in one of the spiral arms of our galaxy, it does contain a number of very nice deep sky objects. And there I've labeled a few. There's my favorite NGC 457, the Owl Cluster. There's NGC 261, known as the Pac-Man Nebula. And then there's NGC 7769, which is a nice open cluster, also in constellation Cassiopeia. Now it is summer, so I guess we should talk a little bit about the summer triangle. And there's the asterism there, made up of Deneb in the constellation Cygnus, the Swan, Vega, Lyra, the constellation Lyra, and then Altair in the constellation Aquila, the Eagle. And there are lots of things to see in the summer triangle, like the Dumbbell Nebula. It is there. It's a planetary nebula, the remains of a dying sun-like star. Another planetary nebula is M57, the Ring Nebula, the remains of a sun-like star at the end of its life. And through a telescope, it will not look all colorful like that. It'll just look gray. And another one is the Coat Hanger Cluster, which actually looks like a coat hanger. Coat hanger is a pretty wide object, so first time I saw it with my telescope, I couldn't actually make out the coat hanger, but when I looked through my finder scope, I could see the coat hanger. And I've talked about this one before. There's lots of other objects within the summer triangle, but we'll save those for later on in the year. We will talk about some double stars in the area, and probably the most famous one is Epsilon Lyra, which we call the double-double. It is 2 stars that are actually 4. There is one set there, and within the same view in your telescope, there is another set, 2 double stars together, but to the naked eye, they look just like a single star, and that is Epsilon Lyra, the double-double. Of course, I guess we can't leave without pointing out the great globular cluster M13 in Hercules. There it is there. It's the brightest globular cluster that we can see in the northern hemisphere. And it's about 25,000 light years away and contains tens of thousands of stars. And it is an object that, like the moon, looks like the photographs when you see it in a telescope. And there's also its not-so-famous companion M92, another globular cluster in Hercules. It's almost as bright as M13. It's not quite as big, but it is fairly bright and can be spotted in binoculars or a small telescope. So I think that's about it for tonight. So I will ask if there are any questions before we move on to the next section. Are there any questions, or anyone have anything to add? Alistair, maybe?
No, covered things nicely.
Okay. Okay, if there's nothing else, I will go on to the moon.
What do you see when you look at the moon? When it's full and round, do you see a balloon? Does it look like a cookie with the bite taken out? What do you see when you look at the moon? It follows a path.
Okay, the moon was full on the 3rd of July, a couple days ago. And the July full moon is known as the buck moon. Also has a number of other names: the salmon moon, the birds shed feathers moon, the raspberry moon, although our raspberries in the backyard have not come out yet, getting there, and the thunder moon, probably from all the storms that we have. Third quarter is on the 9th. The moon is new on the 17th. And first quarter is on the 25th. Now, normally I take, I'd be picking something from the RASC Observe the Moon certificate program for either binoculars or telescopes for my lunar feature. But today I just picked one for myself, bit of nostalgia, I guess. And I call this one the Lonely Mountain. Although I'm not going to be talking about anything from Lord of the Rings or The Hobbit. Now, way back during the Christmas when I was in grade 5, my parents, or maybe it was Santa, gave me this fine astronomical instrument, a 40 millimeter Tasco refractor. And it came with this teeny tiny tripod and a built-in zoom eyepiece, and it would zoom from 25 to 50 power in increments of 5 power. Now, nowadays, I tell people to steer clear of Tasco. It rhymes with fiasco, after all. But back then, in my eyes, it was a fine instrument because, well, it was mine, and it came in this nice box, promising views of the moon and the Crab Nebula and stuff like that. Now, in the box with a Rand McNally map of the moon, and it was a pretty big map. I think it was about 3.5 feet square. And that map hung in my room for over a decade. And I'd study it, and I'd mark the Apollo landing sites, and it was pretty beat up when I finally took it down. Now, one of the features that intrigued me on this map was Mount Pico sitting out in Mare Imbrium. It was just sitting out there kind of by itself. And I would look at it through my little telescope, and I could see it. And when the lighting was right, I could see its shadow on the floor of Mare Imbrium. And there's Mount Pico right there. Or maybe it's Pico. So here's a photo I took of the moon. Not great, but I am the world's worst astrophotographer. And Mount Pico is in the top of that circled area. It's a lone lunar mountain. There we go. In the northern part of Mare Imbrium, just south of the crater Plato, which is the one with the really dark floor. And here's a similar view, an arrow there, taken of the same area by someone who is a much better astrophotographer, someone who knows what they're doing with a camera and a telescope. So Mons Pico is part of a rim of a surviving inner ring of a ghost crater that was created by the impact that formed the Imbrium Basin. It was later covered over by flowing volcanic magma some 3.8 billion years ago. The mountain is elongated. It's 25 kilometers long and 15 kilometers wide, and the peak rises about 2.4 kilometers. The mountain itself is quite bright, and because of its isolated location, the peak can cast prominent shadows by the rising and setting sun. There is a smaller peak to the southwest, sometimes called Mount Pico B or Beta, and this region of the Mare contains a number of ridges, and you can see one there to the right, lower right, next to that crater. This illustration was made in 1874. British astronomer James Naismith, who published a book of illustrations of what the moon would look like if you were standing on its surface. And he based these pictures by plaster of Paris models that he constructed. So this is what he came out with for Mount Pico. Now, the craggy peaks and harsh terrain of the moon would influence artists and filmmakers for decades, including Kubrick's 2001: A Space Odyssey. If you've ever seen any of the classic sci-fi movies in the 50s where they go to the moon, for example, Destination Moon, or as I mentioned before, 2001: A Space Odyssey, you see this craggy surface. But actually, we now know that Mount Pico is not craggy and rough, and it's kind of smooth. It's been blasted smooth by billions of years of micrometeorite impacts. So it is not a big craggy object. It's quite smooth. So you can, and as Kubrick's 2001 showed the craggy mountains, so you can stick that in your tinfoil hat. You Kubrick faked the moon landing people. And that's it for our moon feature tonight. So this month's constellation is Aquila the Eagle. Aquila is located right on the celestial equator, meaning it can be seen in both the northern and southern hemispheres at certain times of the year. And right now it is in our summer sky. So this is the star field. And this is the astronomical drawing. The constellation represents the eagle of the god Zeus in Greek mythology, Jupiter in Roman mythology, and it was first cataloged by the Greek astronomer Ptolemy in the 2nd century. Aquila has 3 stars, brighter than third magnitude, and 2 stars are located within 32.6 or 10 parsecs of Earth, 32.6 light years. And as of now, we know Aquila has 9 stars with known planets. So this is a representation of the eagle. I use Starry Night for this, and the folks who wrote the program included an unfortunate soul in the eagle's talons, and this fellow is Ganymede. And in Greek mythology, Aquila is identified as the eagle that carried Zeus's thunderbolts and was once dispatched by Zeus to carry Ganymede, a young boy Zeus desired, to Olympus to be the cupbearer of the gods. And Ganymede is represented by the neighboring constellation Aquarius. Now, I don't know if this was the first story about giant eagles carrying people away, but it was certainly not the last. And that's the last Tolkien reference I'll have tonight. So the brightest star in the constellation is Altair, derived from the Arabic phrase which means flying eagle. Ptolemy called the star Atus, which is Latin for eagle, and similarly both Babylonians and Sumerians called Altair the eagle star. So all these different cultures were seeing an eagle in this constellation. Altair is the 12th brightest star in the sky. It's only 16.8 light years away, making Altair one of the closest naked eye stars to Earth. And I've mentioned before, the closest star to Earth you cannot see with the naked eye. It's a red dwarf and it's very faint. Altair has 1.8 times the mass of the sun, and it moves across the sky by about a degree every 5,000 years. So it is, in stellar terms, it's kind of trucking along. So here's Altair today. And there it will be in 7,023. So it's moved a little bit, about 2 full moon widths in 5,000 years. And I mentioned in the planetarium portion, Altair is one of the corner stars of the summer triangle. Now, if you're like me, and have a love of old science fiction movies, you'll know that a planet orbiting Altair was the setting for the 1956 classic Forbidden Planet, starring Anne Francis and Leslie Nielsen. Nielsen was known for serious roles at the time before he became a comic actor starring in Airplane. Although in one scene, he did have an opportunity to play a straight man to a robot.
United Planets cruiser C-57D. Now more than a year out from Earth base on a special mission to the planetary system of the great main sequence star, Altair.
When do we get a DC fix, Jerry?
Half a minute, Skipper. There's Altair right on the nose, Skipper.
This is no offense, but you are a robot, aren't you?
That is correct, sir. For your convenience, I am monitored to respond to the name Robbie.
Nice climate you have here. High oxygen content.
I rarely use it myself, sir. It promotes rust.
Gee, Doc.
Aquila contains no Messier object, and to the best of my knowledge, nor any other objects on the bright NGC or finest NGC lists. There are a few objects that are visible in the 3-inch or larger telescope under a dark sky. NGC 6709 is an open cluster, approximately 3,500 light years away. Clusters about 60 stars, many slightly blue, and at about 315 million years old. So these are youngsters compared to our own sun, which is 4.5 billion years old. And there's also a globular cluster, NGC 6760. It's 24,100 light years away, and it contains tens of thousands of stars. Shines at ninth magnitude, so you can see it in a small telescope, but is on the smaller side. It's only 4.8 arc minutes across, and contrast that with M13 and Hercules, which is 20 arc minutes across. So there is the open cluster NGC 6709 and the globular cluster, excuse me, NGC 6760. Moving on to space history. So this is where we look at a past event that not only occurred in this month, but whose anniversary year is divisible by 5. So in 2023's, I'm looking at items that occurred in years ending in a 3 or an 8. Now, we've had a couple solar eclipses in the coming months. A total annular eclipse is occurring on October the 14th. And an annular eclipse is when the moon is near its apogee and does not fully cover the sun. You get a ring of the sun around the moon. So annular meaning ring. The path of annularity runs west to east across parts of the southern United States. Here in Edmonton, we'll see a 53% partial eclipse. The next one is a total solar eclipse on April 8th, 2024, and the path of totality will run south to north from Mexico through Texas up through the Midwest of the U.S. into southern Ontario, Quebec, and the Maritimes and Newfoundland. In Edmonton, we will see a 34% partial eclipse. Although I don't plan on being here, I plan on being in southern Ontario.
Sorry, excuse me, Jeff. I'm
Yeah.
only getting a black screen.
Oh, okay.
Here it comes. It's just late.
That's because I was
Sorry.
just I didn't want to okay. So today eclipse station is pretty easy, and if you have the resources, you can travel by car, plane, or even on a ship to see a total eclipse. If you've never seen one, you have the chance, you owe it yourself to see one. It's spectacular. And ads for eclipse chasing pop up regularly in astronomy and in travel publications. So there's one for Chile in 2019. There's another one. There's one July 10th, 2022, on a cruise ship. This is the one that I went to the States to see. Before You Die. Good advice. And this is for the upcoming one, April 8th, 2024. And of course, with all these people traveling to see the eclipse, there are people who are going to make a buck off of it. Now, in this year's March issue of Astronomy, I read an article on historical solar eclipses, and a couple in the 19th century got my attention. 155 years ago, during an eclipse, the previously unknown element helium was discovered spectroscopically on the sun 27 years before it was found on Earth. And 10 years later, on July 29th, 1878, there was a total eclipse where a team of American scientists observed the eclipse from atop Pikes Peak at 4,300 meters, while a British group set up at 1,829 meters. And comparing their results later, it was found that data from the mountaintop was much better due to the clear, thinner air. And this international aspect caused me to do some more reading, and this is what we're going to look at today. So this was the path of the July 1878 eclipse, and it began in Russia. It swept down through Alaska and the Yukon, through the western BC, where the greatest time of totality occurred, which was 3 minutes and 11 seconds, then across the western territories of the U.S., out into the Gulf of Mexico and into the Caribbean. Papers of the day refer to it as the eclipse of the century, or the Great American Eclipse, and it attracted a great deal of interest from the general public, as well as teams of scientists from across the United States and Europe. Now, in earlier times, getting to the path of totality with all the scientific equipment would have taken weeks or even months. But in 1878, the journey was much easier because they had the railroad. And after the end of the U.S. Civil War, rail lines expanded across the continental U.S. In 1869, a transcontinental line was completed across the United States. And throughout the 1870s, railways expanded across the West. And instead of traveling by horse-drawn wagon for several weeks across the Great Plains to reach the path of totality, people could ride the train with their equipment and arrive in days. Now, newspapers of the day reported a large migration from the Midwest toward the path of totality to view the eclipse, and many people headed for the new state of Colorado, which was admitted to the Union just 2 years before in 1876, with Denver at its capital. And the path of totality would pass directly over Denver, so it became a favorite destination. Others went to Wyoming and Texas, but Colorado got most of the eclipse expeditions. So traveling in relative comfort, and this lady looks sort of comfortable, teams of scientists from the U.S. Naval Observatory, Johns Hopkins University, West Point, and Princeton, to name just a few, all headed west, as well as groups from Europe. And all these astronomers brought a support crew to help transport their equipment, set up instruments, and aid in other aspects of the observations. For the most part, they arrived early to obtain prime observing sites and set up their equipment. One person who did not arrive early was a young Thomas Edison, fresh from inventing the phonograph. Edison was there to test a new invention that could detect infrared light and estimate the temperature of objects remotely, and he planned to try and estimate the heat of the sun's corona while the solar photosphere was blocked by the moon. The tasimeter would be mounted on a telescope. Because total eclipse happened close to home, so very rarely, most astronomers arrived at their observing site early to uncrate their heavy observing equipment and build observing shacks, mix concrete to make steady piers. Edison arrived with just a few days to spare before the eclipse. And so he didn't really have time to build a protective structure, so he used a chicken coop. So on the eclipse day, as the sky darkened, the bewildered chickens came home to roost, literally, disrupting his observations. Some of the many teams of scientists who came to observe the eclipse on July 29th, 1878. This is a group from Princeton University. There's another group with their telescopes set up, all dressed in their finery. It's a whole line of people. Now, to prepare the public for the event, the United States Naval Observatory published and distributed a booklet titled Instructions for Observing the Total Eclipse of July 29th, 1878, and those who wish to record the phenomenon that might help with the advancement of astronomy. So I downloaded a copy of it. I'll just read just a little bit of it. Accurate drawings of it will be exceedingly valuable. Fortunately, inaccuracies such as effects of the scientific value of the drawings can easily be avoided. With this view, persons intending to make sketches should provide themselves with a sheet of paper about 9 inches wide and 12 inches long, having upon it a black disc 1 1/4 inch in diameter to represent the moon. From the center of this straight line are drawn angles of 30 degrees, the whole being an exact copy of plate 1, and there is an accompanying picture. This section is called Observations with the Naked Eye. Nowhere does it mention anything about, proper solar filters, but it does mention one thing here. Finally, 2 or 3 minutes before the beginning of totality, let the observer close his eyes and cover them with a handkerchief so as to make them sensitive as possible. A friend must be ready to warn him when totality begins, and then removing the handkerchief, he must rapidly sketch in the outline of the faint outer parts of the corona, taking special care to preserve the correct proportions. So that was, there's also a section on the photographer too. Now, on the day of the eclipse, luck was on the side of those people who traveled out. The morning dawned clear and bright, and the skies remained cloudless into the eclipse. And aside from being able to witness the event, scientists hoped to use the time of totality to learn about the sun's corona, detect ultraviolet light, and determine whether the planet Vulcan, theorized to be found between Mercury and Sun, actually existed. Now, perhaps more interesting was the discovery of streamers, giant solar rays extending from the sun's corona. These streamers spread outward to a distance of more than 10 million miles, up to 12 times the sun's diameter. It was an extraordinary discovery, and the streamers were most accurately captured by Samuel P. Langley from the summit of Pikes Peak, where the atmosphere was crystal clear. And incidentally, the team on Pikes Peak before the eclipse also dealt with blizzards and altitude sickness. And these are some of the drawings of the streamers. Now, I couldn't find a photo from the 1878 eclipse, but I did find this photo, which apparently is the first photo of an eclipse ever taken. It was taken a few years before. The eclipse was huge news at the time, and this is the August 24th, 1878 issue of Harper's Weekly cover, which was sort of the Time magazine of its day, reporting on the event. So the July 1878 eclipse was one of the first on this continent where the general public, if they had the means, could travel to view it easily. Today, eclipse tourism is big business, but you might say that eclipse tourism got its start 145 years ago this month. So I did a lot of research on this, and I found a lot of photos, and I put together a short little video with a little bit of humor. So here we go.
One trick is to tell them stories that don't go anywhere. Like the time I caught the ferry over to Shelbyville. I needed a new heel for my shoe. So I decided to go to Morganville, which is what they called Shelbyville in those days. So I tied an onion to my belt, which was the style at the time. Now, to take the ferry cost a nickel, and in those days, nickels had pictures of bumblebees on them. Give me 5 p's for a quarter, you'd say. Now, where were we? Oh, yeah. The important thing was that I had an onion on my belt, which was the style at the time. They didn't have white onions because of the war. The only thing you could get was those big yellow ones.
Heavensabove.com is a great source for just about all things astronomical. You can print customized star maps for your area down to the exact minute. There are satellite passes, ISS passes, comets, all sorts of stuff. Next, What's Up is going to be on Wednesday, August 2nd. RSC Edmonton regular meetings take a break over the summer. Our next one is going to be on September the 9th. And with that, I will say thank you for your attention. And if there are any questions or comments, I will take them now. I must apologize. I used them golden slippers for the music. It was actually written a year after the eclipse, but I thought it fit.
Just an extra note, the casual in-town observing looks like we will be doing Saturday night. And so that's just drive right up the main walkway to the observatory at the TELUS World of Science, and we'll set up some scopes there. It's a late one from about 11 o'clock to 1 a.m. That's Saturday night.
Yeah. Thanks, Alistair. That's great. Anything else? No questions, no comments? Rotten Tomatoes? No? Okay. Well, if that's the case, Mitch, thank you. Thank you.
Yeah,
thank you.
yeah, thanks very much.
Yeah, thank you for that. Well, if there's nothing else, I will say thank you for coming to What's Up. This is recorded. I will edit out some of the goofs and post it on the RASC Edmonton YouTube channel in a day or two if you want to watch it again. So with that, I'll say good night and thank you very much.